Hello, let's continue to chapter 3. So chapter 3, we talk about, the process of the product design and then the process selection. So when we talk about product and service design, we would, have to match with the strategy like we talk about in chapter 2, okay? And then the product design would define the product's characteristics. So like we mentioned in the previous chapter, we figure out the strategy and then what's operations strategies, and then what would be our targeted customers, order winner, order qualifier, and then what should we focus on, right? So this should be connected. So the product characteristic, the appearance, what materials you use, the dimensions, tolerances, and then performance standards. So those are the things that we have to set up. And then for industry, then they will have to define the service and the concept. Okay, so it includes the physical element, the aesthetic, and then psychological benefit for service. Okay, so like what's like when we go to a restaurant or go to a spa, okay, the physical element will be the spa product we use, and then maybe the aesthetic will be the design, and maybe sometimes they would how they decorate the places, and then a lot of times they will put on the aroma oil, so when you and then play some music, nice like soothing music. So this and then the psychological benefit, what do you get from the service? Okay, so and then we want to make sure that the staff are friendly, and then whether or not they will like I hate when I need to make appointment, but then I have to wait. Okay, if I have to wait, what's the purpose to make the appointment? So so the product or the service design have to match the needs and preferences of the targeted customer group. So this goes back to when we talk about order winner or the qualifier, the design of this should match to the preferences of our customers. So first step for product and service design is first we develop the idea. So we think of a product or service to satisfy our customers. So think about the customer's need. How do we marketing this product, and then how to design the product. Okay, engineering, competitors, or we can do benchmark or reverse engineering. Yeah, and then we have the product screening. So we'll have some kind of evaluation process, give different scores in different like items or the characteristics, and then calculate it and then compare to to our competitors. So and then we can also look at the break-even analysis, so that we kind of figure, oh, so this we want to add to this product. If we if we want to have certain feature, maybe in the production process we have to get certain equipment, or so is it worth the money? So these are some of the things that we will use to to screen, to help us to decide what product we are going to go for. And then we have the preliminary design and testing. After we have the protocol, and then we'll have to prototype, and then we will have to kind of develop the standard procedures to produce the product, right? So the final design will based on the test result, and then the facility of equipment, what equipment we have, and then the materials or the labor skills we have, so, and then we also need to identify the suppliers, who are we going to work with and how, and those kind of stuff. And then we can use the break-even points to, like I say, to kind of screen out different equipment, different product. Okay. So we can calculate the quantity, the required quantity that we have to sell to break even. So they will give us some idea like, okay, can we reach that? If not, you know, what can we do? Yeah. And then, so we compute the total revenues at some selling price. And then we know the fixed costs and then variable costs for different quantities. So we will plot the total revenue line and then the total cost line. So the intersection is a break even, okay? And the sensitivity analysis can be done when we try to like add or minus the quantity and stuff to see like, okay, if we only sell this quantity, how much are we going to lose? If we sell this quantity, how much are we going to make? Yeah, so those are the usage of the break-even analysis. So one quick example. So a company is planning to establish a chain of movie theaters, and it estimates that each new theater will cost approximately $1 million. And the theaters will hold 500 people and will have 4 shows each day with average ticket price at $8. And they estimate the concession sales will average 2 per patron. So the variable costs in material and labor are estimated to be $6 per patron. So they would, and then they will open 300 days per year. So how many people we need to have for the theater to break even? Okay, so to calculate the break even, the total revenue should be equal to the total cost. Okay. So the total revenue is the selling price times the quantity. How many? That's the break-even point. And then this will equal to the fixed cost, $1 million, plus the variable cost. You know, the labor, the whatever material and labor, $6 times per patron per person. So this will be our break-even. So our revenue will be from ticket, from the what is this? The concession, you know, 10 times Q equal 1 million plus 6 times Q. 6 is the cost. So that means we need to sell 166,666.67 tickets to break even. So it's 28% occupancy rate. Okay, but it doesn't look a lot, but is it 2,000? Oh, okay. Yeah, it doesn't look a lot, but if we divide it by 300 days, so it's how many? 300, about 50,000. That's a little bit more than 50,000 per day. 50,000 divided by 4. So it'd be like 125, 12,500, around that. Okay. So, but what if they sell 300,000 tickets? Okay, so that's the sensitivity analysis we were talking about. Then they can make about $200,000. But what if the concession average is only 50 cents? Okay, so then in that case, we have to sell 400,000 patrons tickets. So the occupancy rate actually more than double. Okay, 67% now. So the ability to sell the concessions are very important. Yeah. So and then so that's the break-even analysis. And then other, oh my God, my dog is playing. Other product design factors, you know, something that people are like they are concerned about is, you know, like when I buy furniture, small furniture from Amazon, I want to be, you know, I want it to be easy to assemble, right? So minimize the part. And it also, even not just for us in the factories, if they can minimize the part, they can shorter the process. It'll be faster to produce. Okay. And then we can design parts for multiple applications. so that we don't have to have so many different type of inventories, right? And then we can use the modular design, like, you know, smaller like workstations, they can do different stuff, and then try to avoid tools so it will be easier, and then, you know, simplify operations. Okay, so, and then some other things to think about is the product life cycle. Okay, so when we have product life cycle in the introduction stage, let me grab my, oh shoot, what do I, man, what did I do? Oh, I just stopped sharing. Okay, still fixable. So it's still recording, right? Yeah, still recording, thank God. So I want to grab a pen. So here, so in the stage, in the introduction stage, there are 4 stages. In the introduction stage, the demand for the product is kind of low. Okay, the price is high. And then in the growth stage, the demand started to pick up. Okay, the price still, you know, relatively high, but then they started to lower the price somewhere like here, and then it started to grow like here. Sometimes some product, they just stay mature, well, mature like this, but some product they might decline, and then eventually, you know, the demand is like they will die down. Okay, so like typewriter or I don't know if you guys even know the PDA, the personal digital assistant. It's like the president, yeah, president of the smartphone. Okay, before we have smartphone, I have the PDA where, you know, I can put in everybody's phone number, and then we can use the, not Blu-ray, but they have some other, I forgot the method to exchange business card, exchange each other's contact. Yeah, and then you know, you have calendars, you have stuff you can put in there. Yeah, so those are the 4 stages of product life cycle. And sometimes because of, you see here, because of the product life cycle, the demand, it will be different, right? So when the demand is bigger, we will choose the facility or process that can produce more product. Okay, but in the beginning, you know, we don't want to invest too much in a mass production, you know, facility. So, you know, so sometimes we also need to think about the product life cycle. And then another thing that we have to kind of think about is the over the wall sequential design process. You know, we try to, like, now we try to break, like, think outside the box. So like before, we'll have different team, you know, working in different cubicles. Okay, but that's not good, because sometimes lack of communication, you know, might design something that it doesn't, like customer wants something, and then the design engineer might design something different, and then the manufacturing engineer would make something different, and then the marketing will be promoting different stuff. Okay, so everybody, if they are not communicating, but now, like, we work in the team to try to figure out what we want to we replace this with the concurrent engineering process. We have teams from different background to design the product, to discuss the product. So the process selection. So there are 5 considerations. Okay, so the first consideration is what type of processes. Okay, and we have the intermittent or to continuous. So these are the type of processes. We will talk about it later. And then how much vertical integration we want, and how flexible our resources are. What's the mix between capital and human resources? Okay, do we want to invest more in capital, or we invest more in human resources? And then the degree of customer contact. Sometimes, like, especially in service, we have more customer contact than the physical product. Okay, so these are the 5 considerations we have. So the first one is the process, type of process. So basically we have 4 major type. There are some in between. So we have project process, and we have batch process, and then we have line process, and then continuous process. Okay, so for the project process, it's like a customer job shop, the customer tailoring, construction. So it's very customized. Okay, so the volume usually are small, and it's very customized. So the standardization is very low. And then we have batch processes, like we have classes in different sessions, okay, every year. So that's like education classes, or bakeries, like when they bake something out. I don't even know why I'm drawing it doesn't look like it, but I try to draw a donut. So bakeries or the printing shop, when they print out something, batch by batch. Okay, so they have a little bit more volume than the project process, and then a little bit less customization. Okay, so a little bit more standardization, but still you can have some kind of variety. Like, have you been to not Dunkin' Donut, what is a Krispy Kreme store? They usually have a machine there. They just make donuts right there, right? So when you see the machine, it makes the standardized donut, the what is it, the standard sugar glass, or I don't know how you call it, like the glass, the normal sugar glass donut. And then sometimes they put different icing or different stuff on top. So that's how they customize it. But it's still, like they can do the customization step in the last step. So they can kind of, so the standardization is a little bit higher than this one, but it's not like assembling line in a car manufacturing. Okay, so the next one is the line process. It's like assembling lines. We follow certain procedures to make the product one by one from A, B, C, D, E, through to H different, process to finish the product, like the car assembly line. And then, but in the car assembly lines, they will have different lines, and they will make, same model. But sometimes it depends on, like, you can make the car here, and then like towards the end, you can paint the car in different colors, right? So the standardization is higher than batch, but you can still kind of customize somewhere, and then you can make different line. Okay, this is supposed to be big, like this, like production line. Okay, it's like huge production line. Yeah, so they follow the step like that. And then the last one, the very high standardized and then huge volume, is called continuous process. Basically like oil refinery, water treatment, or any chemical related. Because usually when we try to have a chemical reaction, you cannot stop the process. Once it stops, the chemical reaction just doesn't work, right? So like if you've been to plastic bag factories, so they have to melt the plastic particles, and then they blow the whole thing, like to make it a big bag, and then they cut it. Okay, they cut it after they blow it to a very thin film, and then when they cool down, it becomes plastic bag, right? So that you cannot stop. Once you stop, it's not the same. Like the particles will not be the same, and the plastic bag will look different. Yeah, so that's the 4 major differences we have in the production process. So the differences between this production process is, so let's just pick few to talk about. So for the product variety, in the job shop, a project, or the batch, their variety is great. But for the continuous, the variety is smaller, okay? And then we already know the standardization. Let's see. So the degree of automation for the intermittent option is very low, but for continuous is very high. Okay, and then the throughput time, like go through the whole production for the project or batch is usually larger. For continuous, it's shorter because it's like it doesn't stop. Okay, so working process inventory more, and then in continuous less. I think it depends. Yeah. So this is some of the differences. And if you can see, like we have several different strategies that they choose different process. For example, the make to stock strategy is we make something and then we put it in the inventory and then we sell it, right? So the customer order is actually here. So we make first and then we put it in inventory and then we will buy it. So this is the pizza, okay? Actually the frozen pizza, okay? And then assemble to order. The assemble to order is they have ingredient, they make those and these, and then they make this, and then the customer will order what kind of pizza they want, okay? Then they will assemble, they will put it together and then deliver. Okay, so that's assemble to order strategy. So you will place order, and then because they already have the prepared crust, they have the dough, they have the ingredient, and then you just order it, and then they will assemble it based on what you need. But we also have the make to order strategy. Okay, so they have the ingredient, and then you are going to order right there. It's like you go to like the very traditional Italian restaurant, you order something and you say, oh, I want this kind of dough, and then different type of crust, and then they will just make everything from there once you place the order. So this one has the highest customization. Okay, so they can make everything to your order. Okay, so those are the different strategy versus different layout, different process choices. And then the volume, low volume usually means we try to use the project or batch processes, and then we have less vertical integration, more resources flexibility because we want to customize, usually low volume, want to customize, less capital intensity, and we want high skill labor. They will have more customer involvement, more customized product, and it's suited for make to order or assemble to order. But for high volume means usually line or continuous process, more vertical integration, less resource flexibility, more capital intensity means we invest more money in the automation in machine. So and more specialized labor to control the machine. Very little or no customer involvement, okay? And then they make standardized product, like when I go get the frozen pizza. Did I tell them I want a pizza with Peking duck pizza? I can't, right? They don't sell a Peking duck pizza. But if I go to, well, not here, but if I go to Taiwan, I can say, oh, can I have a Peking duck pizza? Yeah. So standard customized product. And then it's make to stock strategy. So they make to put it in inventory, and then you just go buy it from their inventory. And then the process decision, vertical integration and or make to buy. So vertical integration means, to the degree the company choose to do process itself, okay, from raw material to sales. So it depends on how deep you want to be vertically integrated. So the backward integration means you move closer to like supplier. Backward integration is you move closer to the primary operation to the supplier. Okay, for example, if Ford, the car company, buy a steel company that they need steel to make the car, right? So that's the backward integration. Forward integration is they move closer to customer. So if let's say Ford, they want to buy some dealership, you know, across nation. So that's, you know, closer to the customer because they actually own some dealership, they bought some dealership. So those are, you know, another type of vertical integration. And then they have make or buy choices. So it depends on, you know, how much it will affect you if you decided to make it or if you decided to buy it. So usually people choose to make because it's probably important to them. Okay, it has strategic importance, and you have the capacity, you have the expertise, and you want the quality to be good, and you can control, you know, the speed. But if usually the company choose to buy the stuff, that usually means it's cheaper to buy and it's less headache for the company. But then you have to think about the strategic impact, whether or not you are like helping your competitor, you are like you are training your future competitor. Okay, like Apple used to buy a lot of stuff from Samsung. Okay, they actually buy more phones from Samsung than Foxconn. But because they buy a lot from them, they started to Samsung, like they learn the technology, they become familiar making the smartphone, and you know, they kind of learn and they develop their own R&D and stuff. So they become the competitor, right? So that's something that you know, sometimes we have to keep in mind. So the cost to make is, you know, we have fixed costs, we have variable costs, right? But to buy, then we'll have more variable costs, but you know, we pay more for variable costs, but it will have to just calculate whether or not it's cheaper. Yeah. So businesses are trending towards less backward integration because you have to basically, like, you have to manage a company that's totally not in your field. Okay, and then more outsourcing. So they want to just ask someone else to make it. So we have another process design tool. We have the process flow analysis. It's a tool we use to analyze and document the sequence of steps within a total process. Usually when we try to do the process re-engineering, we will do this, like, you know, we will create the sequence. And then process re-engineering is, you know, we probably move around different jobs to see whether or not we can make it faster, or we can improve the quality, or we can maybe make different product. So that's the process re-engineering. And then the manufacturing technology decision, automation is one thing. Like, do we want to invest in automation? Will they work? And then the computer aid design software that when we use CAD, we can draw this, well, we can draw something like this and then see if we can re-engineer the process. And then the robotic and numerically control equipment, I don't know how to describe, but they have like, I'll see if I can find it. When you go to some kind of trade show, they'll have this machine, and then they would, like, the machine would try to make some stuff, but you won't be able to tell because they don't follow like the logic of human being. They just calculate whatever the easiest way to, you know, cut something or to draw something. So that's the robotic numerical control stuff. And then the computer integrated manufacturing. So those are the technologies that we use. And then to design services, okay, it's a little bit similar to the product process, but because services, it's intangible product, and then it has high customer contact. So it depends on where we are going to see the customer the most and where they are going to give us feedback. Okay, so usually we substitute technology for people, and then we'll get customer involved, and then we have high customer attention. Okay, so we'll have different type of design based on, you know, whatever we prefer. So for chapter 3, you know, the product or process design have to support business operation strategies. And the steps include idea generation, product screening, preliminary design and testing, and then final design. And the break-even analysis tool is to use to screen the processes to see, you know, which one is more maybe feasible. And then the process design range from project to batch to line to continuous. Design, product design, process selection, decision are linked. And the flow chart can be useful tool for the process re-engineer, redesign. The product process design can be significantly enhanced by proper application of new technology to design service process and product, intangible product with more customer contact. So that's a highlight for chapter 3. And I have to go. Thank you.